Hello, my name is Manfred. I'm going to talk about demystifying PowerShell DSLs. So basically what a DSL is and how they actually work in PowerShell and how kind of easy it is to come up with new languages. Also, maybe you should not do always, but yeah, we'll get more of this later on. So first of all, thanks to our sponsors that make it possible to be here in person again after this weird time we've been through. So many thanks. As already mentioned, I'm Manfred. I'm from Austria, actually, from the southern part. I've been a software engineer for about 15 years now, where I stayed with the company KS Engineers for the last 10 plus years, and I'm basically doing different things, programming languages, all in automotive industry engineering. I've been using a lot of different languages, but PowerShell I just started back in 2016 when doing like infrastructure automation, and I got in touch with Chocolatey, which is an awesome package manager for Windows, and it's like all PowerShell based, and therefore I got kind of the grip of PowerShell and never left it since then. I'm not famous on the internet, but you can find me on Twitter, and I'm doing some community maintenance stuff on the Boxstarter community gallery, and also maintaining the Boxstarter project, which is like an extension to Chocolatey. So I will try to kind of speed run through the first couple of slides so we can get actual hands-on on some code. And if you have some questions, there will be a section at the end. If I'll try to speedrun the first couple of slides and then we'll see. So what is a DSL? Basically, Wikipedia tells us that a DSL is a domain, a computer language specialized to a certain domain. So in contrast to a general purpose language, which is just widely used and you can solve a lot of problems with, a DSL is just focuses on a very specific part. So what are the domains we're talking about? So the classic ones would be like mathematics, physics, chemistry. So these are really domains where you've got really specific languages to solve certain kinds of problems you would usually not want to see in other general purpose languages, because it's kind of weird. So we put these aside in DSLs. But also there's things like data querying, which you're all familiar with, like SQL, which is a domain-specific language for data querying. There's also things like data visualization. So there are a couple of different languages that focus on data visualizations, such as, we'll see one later on, which is Vega. Vega is like a JavaScript DSL that allows us to create graphs like really easy. And you can also embed these Vega graphs in like Kibana and your Elastic Stack if you've got one. There are DSLs for build systems. We'll have a look at Pester and Invoke-Build. And we are going to build a little DSL for IT monitoring. And there obviously are a lot of domains you can think of. So basically, we can create a language for everything where people specialize in and try to enhance their experience by providing natural language for the domain experts. So what is not a DSL? Like PowerShell or C++ or C#. Those are all general purpose languages. This example, I think probably all of you can read this. We just get some host address. We then test if the address is available. If it's available, we print OK. Otherwise, we raise an exception. Doesn't work. So this is not very domain friendly, although you all basically can read it. This would be domain friendly. So there's an active host at this address, right? It should do the same. And when talking about an IT infrastructure monitoring domain, with this in your head, everyone can read it. And so we've got like a what and some properties. And it's really easy to map this in PowerShell into a function. So basically we just create a function and pass in some arguments. These arguments are bound automatically via just the position. So we do use a lot of positional parameters in creating DSLs, although it's not like the nicest thing we can do. But this is actually a point I want to make at the very beginning. We're going to bend and break the best practices a little to a lot. So yes, I know Rob told us we should use the approved verbs and we should create readable code. But we're not trying to create readable PowerShell here. We're trying to create a language that's readable for some domain experts. And in our domain we're talking about, we're trying to create readable code for like sysadmins. So I'd prefer active host via test is host active, although it's not that much of a difference, but you'll see why we do this in a second. So we want to come up with something like this, where you've got sections like a host, which is like build server 01.my.org, and we specify there are some services that should run on this host, and there should be some Chocolatey packages installed. So I'm a bit biased towards Chocolatey. You can install software with whatever you want to do, but it's just so much easier when you've got the package manager and just a PowerShell script that gets executed, and really doesn't matter if you've got MSIs or X's or whatever. Just use whatever you want. I named the keyword Chocolatey because I just checked that the package is installed. You can also just rename it to applications or whatever. Doesn't really matter. So basically, I want to create a DSL with such a structure. So who of you has been using PowerShell DSLs before, like Pester? Couple. Invoke-Build. Awesome. Saki. Okay, PSHTML. So those are all domain-specific languages for a certain purpose, and there are others as well. So we will have a look at some of those. This is a basic Pester structure. Hi, Jakob. So Mr. Pester is here also. Yeah, so in Pester you basically get this structure where you can describe then in a context something should hold or something should not hold. And it's really readable when you think about you're in the context of testing something. One thing about Pester and other DSLs, which kind of is problematic, that they all are extending DSLs. So it's just PowerShell, where you can put script blocks everywhere. So I kind of took it one step too far here, but really it's the same structure as we've seen before, just with script blocks everywhere. Invoke-Build, the next example, is also extending DSL. Here we are really focused on building stuff, so you can use like the use keyword to say, okay, I'm going to use this version of MS-Build. And wherever you are calling MS-Build, such as in this line, it will use the specified version. There are additional tasks which can be used to like create dependencies among certain tasks. You guessed it. And as in this example, we've got like a default task, and this default task builds and then cleans it. Everyone. So you can really create some cool dependencies with Invoke-Build. Also, just the same as with Pester, you can put script blocks everywhere. So you basically just have PowerShell, which some certain additional properties or language keywords. So most of the DSLs got like a helper function or a commandlet that you use to invoke this certain type of DSL, which basically does nothing more than importing the module that specifies all the functions that are additional, and then runs the script like in plain PowerShell. We will also do this for our infrastructure DSL. There should be an image.
Animation. Oh, there was.
Map. Right. So sorry for that. Yeah, it's early. We'll just have a look at Pester and Invoke-Build now. So the first demo. Here we've got some Pester code. I'm not using all the features of Pester, I just want to show you how it's basically done. So we've got this describe block. We can add some text, so we describe some basic environmental checks, and we can also create context. And in this context, we create some it blocks, and then we do some shoulds and should nots. Yeah, and I'm just going to run this. Second, invoke Pester, and it ran through. There are 5 tests passed. If we want to, second, I always forgot the output format. No, not output format, the verbosity.
Just output.
All right, detailed, yeah. So we see our context, we see our checks, and we see that these checks pass. So it's like really easy to verify some stuff, to test that certain conditions hold. This is what Pester is good for. This is where Pester excels. And yeah, if you do not use it yet for testing things with PowerShell, I highly recommend you do. Let's have a look at Invoke-Build. Invoke-Build is kind of a similar structure, or basically all of the DSLs we're going to have a look at have got some similar structure. Here we've got some keywords, we've got a name which could be a string, but it really doesn't have to be there. And yeah, then we've got some dependencies such as test depends on build. And yeah, we also have got a clean task, just going to run this. This build is going to just create some C++ C application, compile it, and test is going to verify that it does output some expected result. Oh, task build. So I've got no default task in here, and it succeeded. Just going to add a default task. Task default is build. Actually, let's do clean build test and run this again. Oh.
We can say that the transformation task default. Yeah, that's what it says. Lost the point line.
Oh, it's file. Sorry. So yeah, now it worked. So Invoke-Build's got some useful feature that looks up your current directory, and if you've got any file named .build.ps1 or something.build.ps1, it just tries to execute it. So it basically takes the first one. So you would be able to just say invoke-build, build invoke-build test, and it would look up the file. And this is where I just pitfalled into, because I did not specify a file parameter. Therefore, it took the first file and wanted to execute the task demo02, and which doesn't exist. So what we can see here now is that it actually did clean, build. So it did clean, it did build, and then it wanted to do build again because test depends on build, but it saw that your build has already been executed, and it just skipped it. So this is something that's really handy. You can define like dependencies, and it resolves them for you and executes it in the correct order. So Invoke-Build, Pester, just really basic examples. So I've been talking about those extending DSLs and how Pester and Invoke-Build are extending the PowerShell language. In our case, when creating an IT infrastructure DSL, or at least say, I do not want to extend PowerShell. I really want to restrict what we can do when creating such a language. So what are the keywords we want to support? We want to support host, like for specifying a host. Note that I moved away from active host, which we had in the beginning of the presentation, because now I thought, okay, let's add a block to it and add some additional properties, and such as services, etc. And it's not only that we want to check if the host is active, we want to check some more properties. Therefore, we changed the naming a bit. We want to specify a timeout, so the host could like be an old computer in a remote location, so we could increase the default timeout. We could use some the services keywords to specify some services should be installed and running. We could use the chocolatey keyword, and those are all optional. So if we just state host and an IP address or a host name, we check if it's available. Otherwise, we do some additional checks. So we do not want to extend the PowerShell language, because if we would, then we potentially would be able to run some arbitrary code against a large portion of our infrastructure. As you imagine, these checks will communicate over network. These will communicate with the computers we're checking, with the hosts. And when doing such a thing, I really want to limit what's going to be executed on all of my servers. So We do not want to execute stuff just by doing things like this, which is something that's really easy in PowerShell, but we want to restrict it. And when you've got an extending language, this always will be a problem. So this is kind of obvious, but it gets worse. It gets worse when you do something like this, because you can just use like a double-quoted string to have some code executed. So we do want to leverage what's already been done. I showed you Pester, I showed you Invoke-Build, and Pester is really good at testing stuff. And we want to reuse a lot of it, such as the output Pester provides us with. So we're going to create a DSL that builds up on what Pester already gives us. So as I already mentioned, there are some security constraints or faults we might come up with. So basically, I want to check my code before it's being executed. PowerShell actually does give us the data section. And with the data section, we could limit what Cmdlets are allowed in a script block. But this is kind of too limiting for what we want to do most of the time. So I typically use ANTLR, which is another tool for language recognition. It allows us to define a grammar in a so-called grammar file. If you know bits of regex, you'll be fine. It's really easy. And we use ANTLR to just create a parser in Alexa, where Alexa is basically, it tokenizes the input and says, okay, this is a word, this is a word, this is a word. And the parser then checks if the structure of these tokens is okay or not. So infrastructure, grammar file can look something like this. So this is actually a draft I made for the infrastructure DSL, where you do things like, okay, when we define a host, we want a host keyword, then some quoted text, and then there might be a body or not. So see, it's kind of regex-ish. You have to put a semicolon on the end, and you've got like keywords. So keyword should be host. Then qtext should be like a quoted text, where you've got a single quote, which is just a single quote. Then you've got some text, which is not a single quote. You've got, okay, this is maybe a bug, 0 too many of these. And then you've got single quotes again. Okay, so this is how you define. Those pictures are not working that good. So it's a demo again. Let's check ANTLR. So I've created a Invoke-Build script again for our ANTLR grammar. So this is actually the full grammar of the infrastructure DSL. I've changed something just 30 minutes earlier because I had some issues because I wanted to make the grammar prettier. But yeah, I'm just reverted it so all the demos will work, hopefully. So what have we got here? Basically, on top level, we want to have either a remote user spec or a host definition. A remote user spec can be just remote user and then a username, because you want to connect to different servers and you might not always use the same username to connect to these servers. Then we've got like the host definition. The host definition is just host. It's really just the structure we've seen before. So I won't go through everything of this. Just notice it's just 28 lines of code, and I actually commented bits of it, so it's not that complex.
What's the G4 infra-health G?
It's ANTLR grammar version 4.
Ah, okay.
So ANTLR is, I think, at grammar version 4. It's a bit more complicated than version 3 was, but all of the tooling now basically uses G4, and there are a lot of examples on GitHub and grammar for different languages you can already parse. But if you want to like create a new language, you obviously have to come up with this your own. But there are a lot of examples you basically can copy paste, and these also will be on GitHub, so don't worry. So okay, I had an example for unsafe strings, but I think as we are already good in time, I will just skip this. So, yeah. So, I think all of you can relate that this is something that is a potential problem in PowerShell, and then that we would want to validate our inputs and not have some script injection possible in the infrastructure DSL we're trying to create. So the demo 4 is actually we built, just let me expand this. Damn it. Okay. Nope. Whatever. Okay, we generate some Java files because ANTLR typically creates a Java parser and Lexa. There are other languages too. I'm working on Linux. The .NET version actually requires Mono or .NET framework, so I played with it for 30 minutes and then I just fall back to Java. So it should not be complex to have it run in .NET on Windows, so you would not need to use Java, but yeah, it was the first thing that basically worked out of the box. So we compile this grammar, which is just ANTLR 4, and we pass in our grammar file, and we specify where those files should go to. And we define it should be in, infra parser. And then we get such a parser and a Lexa, which basically is auto-generated and it validates the grammar for us. So I'm just going to... No, okay. Let's Invoke-Build again, and I'm building demo 04 ANTLR, and I'm missing the dash file again. So it did clean, which is the default, unfortunately, I guess. Oh, it's the first, yeah. So task build. Okay. Generate, we compile some Java files, it all works without an issue. And now we've got some tests. So whenever you're creating a domain-specific language, I would warmly recommend that you think about how the grammar should look like in advance, which we've already done, and then kind of come up with some tests of what the grammar of valid and invalid grammar. So I've created like minimal structures, which this here. So we've got just 2 hosts. We've quoted host names. Invalid would be just the same unquoted. Invalid would be double quoted. This would be invalid because we've got a double quoted string here. Valid would be the same, just single quoted. Invalid would be when we're missing like a top level host and just specify services directly. And a bigger valid structure would be something like this, which is what we're already actually going to test. So I can now use task test, which will actually call Invoke-Build and then invoke Pester on these files. And we successfully parse all valid files, and it fails to parse invalid grammar, which is what we want it to do. So now we've got this grammar, and we are able to check whether a file is valid or not. Okay, now we've done this, and we can basically implement our DSL, what I think we're here for. So let me see. Yeah, and also we're going to create like a DSL launcher. So Invoke-Build, invoke Pester, invoke infra-check, where we will pass a file into and have an additional switch parameter if we want to get the output, which will be Pester output, or just print it to the console. So yeah. Demo 5. Okay. Before we're doing the invoke infra check, we just trying a really simple example of how this should look like. We're creating a basic PowerShell file that contains the function calls, and we're going to step into using a VS Code debugger. So this is something I do for my demos. I remove the old modules, with which I may already have loaded in the console. This one starts a virtual machine we are using to connect to when doing the infrastructure checks. And then we're going to import the infrastructure module, which defines the remote user, the host, the services, etc. And then we're actually just running it as if it was, and it is, normal PowerShell code. So let's have a look at this module. So basically, I kind of tend to use requires whenever I can. Just depends. Oh, and notice I am actually using an older version of Pester, which is version 4. I highly recommend you use the current one, which is Pester 5, because Pester 4 is not supported anymore. But when doing this kind of stuff, it's like easier, or it was easier for me to use Pester before, because it does not have this discovery and run phase. So Pester 5's got a 2-phase process, and if you want to just run through all of your script code once, it's easier with version 4. Otherwise, you would have to restructure. It's possible, but yeah. So we've got these keywords, and we'll start just from, actually, remote user can be a top level or a nested one. So let's start with remote user. So remote user, the keyword remote user just takes one parameter, and it's mandatory. It comes first, which is the username. And whenever so let's put it this way. DSL code is not necessarily the cleanest, but you've got to do some things like setting global state, because, it's how it works. So when we've got the remote user keyword, we just get one parameter, and we store it, because we're going to need it later. Now we take a look at host. So at host, we got 2 parameters, the first one being a computer name, the second one being a script block. And this is something you are going to see a lot of times, a DSL taking a script block as last parameter. So there's another style where you can also do dangling hash tables at the end, which might come in handy at some times, but usually it's just a script block. So you do something and then append a script block to it. Notice how this script block is not mandatory. So we can also say just host and some computer name. Then there's a function that's inside this function, which is set remote connection details. I use this to just limit the scope where this function is visible. And with set remote connection details, I basically create another global variable where I put in the host name and the username, depending on the operating system I'm on. If I'm on Linux, I'm using hostname. If I'm on Windows and you need to use WinRM, I'm using the computer name. This is just some basic helper so I can run this demo from Windows and Linux. So then there's something that's really interesting. I'm using the describe keyword in my DSL, which is basically integrating Pester or building up on Pester and extending it. So when defining host something, we're actually kind of doing describe something. We just add host and then pass in the computer name. So basically we're creating an alias, adding some stuff. It's not really an alias, it's just doing something more, but ultimately doing this describe block. So whenever we say host, it's actually describe for Pester. Then we set up our remote connection details, which we'll need to connect to the host to. And then we've got an it block. And it is active. Actually, is the very first thing we saw in this presentation. We just test if the connection to this host is possible. And then we have a should, which is also again Pester, and we check that the status is successful. So it should be reachable. What comes next is actually the most interesting part about how such DSLs are created. So we might have a script block, and if we have a script block after host, we will evaluate it. And inside the script block, there may be nested commands, such as services or chocolatey. I'm just going to show you services now because the time is running short. So with services, we need, it's mandatory, an array of strings. And we create a context, again, in Pester. We get all of the services that are available on a remote computer. So this is where we use this global variable, which we specified the host name and the username, which we use to connect to. I kind of tend to always use key-based authentication. Of course, you could also use like the credential one, maybe store your credentials in a CLI XML or get them in from somewhere else, like the Windows Credential Store. Depends. So you would have to wire it up a bit differently, but ultimately it doesn't matter. So I get all the services, and then for each service I passed in, so this is the comma-separated list we defined in our DSL, we check that this service is up and running on the remote host, and again we do a it block and check has service installed and running. Okay, so this basically is the core that's necessary to run the domain-specific language we saw in the beginning. So when I run this example now, just going to do demo 05, PS1. It ultimately uses Pester to check that some conditions hold. But we did not write Pester code. We did write some hopefully easy to understand code. It's still code, but it's more like really easy to understand and really specific to the domain. So here we check that this host, which is AD controller 01 at my org, has Win management service up and running and has these chocolatey packages, which are basically a couple of service packs and Windows updates, PowerShell, ripgrep, and Vim installed. Okay, and then there's another host, and we just check that it's accessible. So here we've got the first one, we check it's active, we've got the context services, we've got the context chocolatey, and we see all these it blocks get generated along the way when we make our way through our DSL functions. So, okay, then we've got the demo 6. So this was like the basic structure. And if we like complete it, we've also got another function which is Invoke-Infra-check. And with Invoke-Infra-checks, we basically get a file and a pass-through parameter. Then we test if the infra-check syntax is okay. And here we invoke our ANTLR infra-parser and see if it outputs okay or exits with an error. And then, again, we invoke Pester on this file after we check the syntax. So not much going on there. And yeah, I've got a test file for this also. Yeah. So again, I'm removing the models I might have loaded before in other demos. Then I just import my infra-check module, and then I say invoke infra-check. So I think this is something we all know. Just import some PowerShell module we need, and then we've got this invoke infra-check commandlet, and we just say invoke infra-check. Demo 06. Invoke infra-check. So this should work. And we see syntax okay. So the syntax check was okay. We know we've got nothing to worry about in this file. The checks run through. And also, I passed pass-through, the pass-through switch. So we've got this really pretty Pester object we can now use and do something more with. So we could actually create some NUnit XML, whatever. We've got the output. See what we need it for. Just invoke infra-check. Now we're going to pass in a file that's got some invalid characters. So basically these files are kind of identical. The only difference is that here in this bad file, I used double quotes when specifying this one service. So, and this is something that can happen, but if you allow something like this, you're also open and vulnerable to like script injection. So we're just running this again. And we get an error, which is exactly what we want to have. It actually tells us, look, in line 6, there's this character. We don't want to have that. It's invalid. And we don't even run PowerShell against this file. So we bail out earlier, which is nice. Okay, so we kind of came up with a new DSL, or we actually did come up with a DSL. This is our input file. We specify remote user. We specify, okay, there are 2 hosts. This one's got like a little bit higher timeout than what's the default. We specify these services need to be up and running. These structured packages need to be installed. Done. We can use this to validate. Okay. Now, I tend to overdo it a bit with DSLs. And so just because you can do something doesn't mean you should. But you can chain DSLs, which we have already seen with Pester, which we used in our DSL. So when you do, like, who's using Elkstack? Kibana, Elasticsearch, someone? Okay. In Kibana you can create like a lot of really pretty charts, but you can do more with things like Vega. Which you can use to like transform input data, and yeah, basically it can do a bit more than the typical Kibana dashboards. And it's really easy to come up with another DSL, just like basically PSHTML, that creates us a valid Vega specification for Pester output. So this is why I actually wanted to pass through Pester output, because when we create another DSL for a Vega-Lite chart, then it doesn't really matter if the output comes from our infrastructure DSL, which outputs the exact same structure as Pester, or as any other Pester test file. So if we create this DSL, we are actually able to create charts for all of the Pester tests we already got. So actually running a bit low. So I'm, just show you the. So we've got this function Vega-Lite chart, and here is a demo. So again, I've got my keywords like bar chart, title, encoding, which would be what you actually would use when you would write the JavaScript version of this DSL. So you tell there's an x-axis, there's a y-axis. Please use color based on this property, and you give it a title. And then we can say, okay, please use this test file. We use invoke infra-check on one of our files. We can use invoke Pester on one of the basic Pester demos. And I'm just going to show you what this does. cd Pester to Vega. Oh, I actually did enable the verbose mode, which is something I did not want in the beginning. Okay. Start this again. So you see we output some, we put something on the output pipeline, which is basically HTML and JavaScript. And somewhere in the middle, we run Pester, which then is used to create the data that's shown in the graph. And if we look into this, it's really the same structure, or basically the same as we did earlier with our infrastructure DSL. We've got a top-level keyword, which is Vega-Lite chart. In this case, we take just script block. It's a commandlet, so we can use the verbose switch on it. We do some write verbose output, so we can see when what block is put onto the output pipeline. And in the test block, which is, I think, the most interesting one, we just got the script block that we invoke and pass the output to. So this test block basically wants an object that has some test results, and this is what a typical Pester output would include. Yeah, and from this we can create some additional hash table we then use when creating the bar charts. So it's really nothing special. We just create, let me see, how do we get our HTML output structure? So maybe this is something that's interesting for you. So when creating a Vega-Lite chart, we actually output basic HTML, so the head, and then in the body we execute a script block, which will eventually contain a bar chart, and the bar chart will contain a div and some JavaScript, and the JavaScript actually will work on this div. So we basically output some strings to the pipeline, and because I'm really running low of time, I'm doing Pester to Vega. I'm taking the output that's on the pipeline, say out file, PSConfDemo.html, encoding UTF-8, and we're going to run this. So I'm using again demo 6 infra-dev. So this runs our infrastructure checks again, takes the output, puts it into some HTML and JavaScript, and now we should have PSConfDemo.html that contains, okay, it's not necessarily the prettiest graphs, but we see our tests passed. We've got like 2 graphs, the first one showing all the tests, the second one showing the host we connected to. And you can just take this and include it into one of your dashboards. Well, I'm a bit out of time. And my presentation, yep, that works. So, sorry for rushing through. Thanks for your attention. And if there are any questions, I'd be glad to answer them now. Yes, please.
Where do I start a little bit because I followed through, well, 50% of it, and the other 50% is so new. Where would you point me at to actually get some example codes to get things going, especially with the checking of the content, of the grammar and stuff?
Okay, so basically there are 2 things you should check out. First of all, when you want to learn more about PowerShell DSLs, please check out this guy called Kevin Marquette, which is kind of famous, and check his talks on DSLs and Code Golf, which is also pretty cool. So I'd suggest looking up Kevin Marquette and DSL and Code Golf, where you will gain lots of information about how you can do such things. And then just head over to ANTLR.org, which is the ANTLR website. They've got plenty of demos on how to create grammar and validate if it's correct or not. So, and then you basically just combine these the way I did. So you first check if the file is correct, and if the file is syntactically correct, then you can use whatever, just run with PowerShell, use something like Pester, as I tend to do. Yeah, so I just combine these 2. You're welcome. Anyone else? No? So I'm outside later, basically somewhere around having a coffee. Please feel free to ask me anything. Thanks.